Assalamu alaikum. Welcome to my video tutorial on binomial expansion. So let's begin with binomial expansion. In the binomial expansion, first thing that you need to know is the NCR function. How does this works? So NCR, where n is the integer value, r is also an integer value, positive integer both. Now NCR means, so for example, I have 5c3. NCR is equal to n factorial over n minus r factorial times r factorial. So if you have 5 factorial, this would mean 5 times 4 times 3 times 2 times 1. Okay, so 5c3 means 5 factorial over 5 minus 3 factorial times 3 factorial. Now you can easily evaluate this with the calculator, but just for an exercise, this would be 5 factorial over 2 factorial times 3 factorial. 5 factorial can be written as 5 times 4 times 3 times 2 times 1, but I can write 3 times 2 times 1 as 3 factorial over 2 factorial, which is simply 2 times 1. Okay, 2 factorial times 3 factorial. Cancel, you simplify this, you get 5 times 4 is 20 over 2, 10. That is why when you press 5c3 in your calculator, you get 10. So let's come to the exercise. Binomial expansion using the NCR method. Binomial expansion is used to expand a certain expression raised to the power of n, and where n is a positive integer. So the formula would be nc0 a raised to the power n b raised to the power of 0, where a is the first term, b is the second term, plus nc1 a raised to the power n minus 1 b raised to the power 1, plus nc2 a raised to the power n minus 2 b raised to the power of 2, plus nc3 a raised to the power n minus 3 b raised to the power 3. This will keep on going until you reach ncn a to the power n minus n is 0, b raised to the power of n. Now notice one thing, that when you add the powers of a and b, you get exactly the power n. N minus 1 plus 1, n minus 2 plus 2, n minus 3 plus 3, n. One more thing, let's say if we have 3 plus 2x raised to the power 5, if you work this out, you will get 5 terms. Okay, so any expression raised to the power 4 will have 5 terms. How would you evaluate this? 4c0 3 raised to the power 4 minus 0 b, which is 2x raised to the power of 0. 4c1 3 raised to the power of 4 minus 1 3, second term, which is 2x raised to the power of 1. 4c2 3 raised to the power of 4 minus 2 2x raised to the power of 2. 4c3 3 raised to the power of 4 minus 3 2x raised to the power of 3, and final term would be 4c4 3 raised to the power of 4 minus 4 b, which is 2x raised to the power of 4. If you simplify this and evaluate each term, you get this. So notice there are 4 terms. The coefficient, the constant term, you can call this as your constant term or independent term, independent of x. This is the coefficient of x square, x cube, and coefficient of x raised to the power of 4. Now if we are asked to find any particular term in the expansion, the general formula for any particular term would be NCR, the first term, which is a raised to the power n minus r, b raised to the power r. So let's say I have been asked to evaluate the term in x raised to the power 5 in the expansion 5 minus 2x raised to the power of 8. So any particular term will be written as 8cr. ठीक है, the first term would be 5 raised to the power of 8 minus r. The second term is minus 2x raised to the power of r. Now it's advisable that you separate all the terms that will make up your coefficient. So 8cr is a part of the coefficient, 5 raised to the power of 8 minus r is a part of the coefficient, minus 2 raised to the power r will also be a part of the coefficient, and x raised to the power of r. You want to find the coefficient of x to the power of 5, the term in x raised to the power of 5. So if you compare the left hand side with the right hand side, this is what you need to evaluate. So you need the value of r. Okay, now if you use comparison on both sides, x raised to the power r is equals to x raised to the power of 5. Therefore you can figure out that for the term in x raised to the power of 5, the value of r must be 5. Okay, so you can plug that value over here. 8c5, 5 raised to the power of 8 minus 5 is 3, minus 2 raised to the power of 5. And if you evaluate this, you will get negative 22,430. So this is the term in x raised to the power of 5. Okay, so let's look at one more example. Let's say you are being asked to find the coefficient of 1 over x cube in the expansion of 2 minus 3 over x to the power of 7. Any particular general term in this expansion of 2 minus 3 over x raised to the power 7 would be 7cr 2 raised to the power of 7 minus r minus 3 over x raised to the power of r. Okay, now if you separate the coefficient part, 2 raised to the power of 7 minus r minus 3 raised to the power of r, 1 over x raised to the power of r. Now you need to evaluate the coefficient of 1 over x cube. Okay, so there will be a term with 1 over x cube. So if you compare the powers of x's, 1 over x to the power of r equals to 1 over x. 1 over x cube can be written as 1 over x3, right? Therefore you can say that r is 3. Once you know the value of r, what you can do is you can substitute for r 7c3 and find the coefficient. 2 raised to the power of 7 minus 3 and minus 3 raised to the power of 3. So the coefficient will be this. You can work that out. Now let's look at this question. It's a past paper question. In the first part, you are being asked to find the first 3 terms in ascending powers of x in the expansion of 1 minus x raised to the power of 6. Okay, so the first 3 terms only, 1 minus x raised to the power of 6. So the way you go about this question is you expand it. 6c0 1 6 minus 0. You don't need to write 1, but just for your understanding I'm mentioning 1 over here. Minus x raised to the power of 0 plus 6c1 1 raised to the power of 5 and minus x raised to the power of 1, 6c2 1 raised to the power of 4 minus x raised to the power of 2. So if you simplify this, you get 1 minus 6x plus 15x square. Okay, you were only asked to expand it till first 3 terms. Now for 1 plus 2x raised to the power of 6, you will do exactly the same thing. The first term would be 6c0 1 raised to the power of 6 minus 0. Second term, which is 2x raised to the power of 0. 6c1, so 6 minus 1, okay, 6, so the power of 2x would be 1. 6c2 2x raised to the power of 2. You were asked to only expand it till the first three terms. So solve this and you get this expansion. In that second part, you need to find the coefficient of x square in the expansion of 1 minus x, 1 plus 2x, the whole thing power 6. Well, you can simplify this and write 1 minus x raised to the power of 6, 1 plus 2x raised to the power of 6. And you have expanded 1 minus x raised to the power of 6 up till the first three terms, and these were 1 and these were 1 minus 6x plus 15x square, and the first three terms for 1 plus 2x raised to the power 6 were 1 plus 12x plus 60x square. Now you need to multiply them in such a way that you obtain x square. Okay, so the first term, the term 1 would be multiplied by 60x square, minus 6x would be multiplied with 12x, and 15x square would be multiplied with 1. So the terms are 60x square minus 72x square plus 15x square. So you get 3x square. So the coefficient of x square is 3. Okay, in this question you are being asked to find the terms in x square and x cube for this expansion. So again, applying any general term in the binomial expansion is given by NCR a n minus r b raised to the power of r. This is for any general term in the binomial expansion. Therefore, if you want to use this, so you will say 6c r 1 raised to the power of 6 minus r b, which is minus 3x over 2 raised to the power of r. Now 1 raised to the power of anything is 1, so I can neglect that. 6cr minus 3x over 2. Well, you can separate the coefficient part and the variable part. Now the question says find the terms in x square and x cube. So if you just equate it to a term in x square and then to a term in x cube, you will realize that r is 2 when you equate this to over here, and when you equate this to this, r will be 3. So the coefficient of x square would be 6c2 times minus 3 over 2 raised to the power of 2, which is 135 over 4. And when r is 3, so the coefficient of x cube would be 6c3 minus 3 over 2 cube. So the answer would be minus 135 over 2. So that's your term in x square, and this is your term in x cube. In the second part, they are saying that given that there is no term in x cube when the two things being multiplied, find the value of the constant k. Okay, so you already know that the expansion, that the term in x square and x cube in this expansion would be 135 x square over 4 and minus 135 over 2 x cube. Now in order to have x square ka term, x cube ka term, right, this k would have been multiplied by this term and this x term would have been multiplied by x square term. So minus 135 over 2k x cube plus 135 over 2 x cube. If you simplify this, you get minus 135 plus 135, just a second, minus 135k plus 135 over 2 x cube. Now they were saying that there is no term in x cube. Okay, so there is no term in x cube, so that the only possibility that you cannot have a term in x cube is that when the coefficient of x cube is 0. So minus 135k plus 135 over 2 is equal to 0, and therefore if you solve this you get k as 1, and that was asked in the question. Now in this question, first of all you are being asked to find the coefficient of x raised to the power 8 in the expansion of x plus 3x squared raised to the power of 4. So the same step again, 4cr, because we don't know the term, x raised to the power of 4 minus r, 3x squared raised to the power of r. Okay, separate the coefficient part. Yeah, now you need to evaluate the term in x raised to the power of 8. Therefore, if you equate the x powers, you get 4 plus r equals to 8, and r is 4. Okay, so the coefficient of x raised to the power of 8 would be 4c4 3 raised to the power of 4, which is 81. So that's your coefficient for x raised to the power of 8. Similarly, in the second part, you have power 5 and it's x plus 3x squared raised to the power of 5. So any particular term would be 5cr x raised to the power of 5 minus r 3x squared raised to the power of r. Rearrange it and make the coefficient separate and the powers of x separate. So you get 5cr. This is after simplification. So yeah, you can simplify it like this, and that done in the previous part. Now you can compare it to x raised to the power of 8. So comparing x key powers, you get r is 3. So when r is 3, the coefficient would be 5c3 into 3 raised to the power 3, which is 270. Okay, so for the third part, hence find the coefficient of x raised to the power 8 in the expansion of whole of this thing. So the way you go about this question is, you have been given 1 plus x plus 3x square, the whole thing power 5. Any general term in this expression would be 5cr, a, which is 1, so I will not bother to write 1 now, and b raised to the power of r. Now r की value क्या होनी चाहिए that you get x raised to the power of 8? See, if r is 1, okay, so x plus 3x square raised to the power of 1 would, the highest power of r you can get over here is 2. When x plus 3x square raised to the power of 2, the highest power you can get is x4, but you want 8, right? So for that, r should either be 4, because x plus 3x square raised to the power of 4, this will give highest term in x raised to the power of 8, and the value of r should be 5, so that x plus 3x square raised to the power of 5 will give you highest power of x is 10. Okay, so this would be 5cr. यहाँ से आपको r की दो टर्म्स चाहिए, x plus 3x square raised to the power of 4, okay, plus x plus 3x square raised to the power of 5, because you can have x की power 8 from this term as well as from this term, as we did in the first two parts. Now 5cr times x plus 3x square raised to the power 4. Since we have said that r is 4, then you can place r की value over here as 4. Similarly यहाँ पे हो जाएगा 5c5 x plus 3x square raised to the power of 5. अच्छा जी, so 5c4, what was the coefficient of you want to find इस एक्सपेंशन में x raised to the power of 8, ठीक है, और इस एक्सपेंशन में भी. So the term over here was 81. The coefficient of x to the power of 8 was 81, and the coefficient of x raised to the power of 8 in this expansion was 270. So when you simplify this, you get 675 x raised to the power of 8. So the coefficient of x raised to the power of 8 would be 675.